everyone, today I'm doing something a little different. This video is about how to solve a Killer Sudoku puzzle, which is a variant of the Classic Sudoku puzzle I typically do on this channel. On the left here you can see a Killer Sudoku puzzle, and on the right is a Classic Sudoku puzzle. Notice the difference. Both are 9x9 grids, but you'll notice the Killer Sudoku on the left has no numbers given, but it does have these dotted lines that are called cages, and some of them are made up of 2 cells, some 3 cells, and so on. In the upper corner of the cage area is a number. So now how do we play this? Well, all of the same rules for Classic Sudoku apply to Killer Sudoku. That is, you have to fill the grid with the numbers 1 to 9 in a way that each row, column, and block contain each number 1 through 9 exactly one time. But for Killer Sudoku, the sum of all the numbers in a cage must match the small number that appears in the corner of each cage. So, for example, this is a 2-cell cage that sums to 8. So that can be a 1 and a 7, a 2 and a 6, or a 3 and a 5. Notice that I didn't say a 4 and a 4, because obviously you can't have 2 4s in the same row. But what if the cells didn't line up in the same row or column or block? That brings us to one more rule, and this is important. No number can appear more than once in a cage. So the numbers for this cage can only be a 1 and a 7, a 2 and a 6, or a 3 and a 5. That's too many choices, so the first strategy in Killer Sudoku is to look for cages that have less choices. Make sense? This puzzle is from dailykillersudoku.com, and you can try this puzzle yourself by going to their website, scroll down to where it says Archives, and then type in the puzzle. This puzzle is 30458, and then just click on Go. You'll see the puzzle there, and it's rated a difficulty of 2, so a nice easy one to start. And now click on Try It Now, and here we have the puzzle. Notice on the right side is a tool for combinations, so when I click into the 2-cell cage with an 8, you'll see in this box all the possible combinations. So that's really too many combinations to consider. So back to the first strategy that you should use when you solve a Killer Sudoku puzzle, and that is to look for cages that have less choices, obviously. For example, this cage down here consists of 2 cells, and the sum is 3. So it can only be a 1 or a 2, and I can enter those candidates very easily. Now back to this handy tool for all the combinations. This is really very useful, so if you want to use it, that's great, but if you don't want to use it, you can toggle it off, but I don't see why, because it is very helpful. So for example, if I click here on 14 with 3 cells, you can see that's a lot of combinations of numbers, and that's really too many. When you start out, a good first strategy is to look for extremely low sums or extremely high sums. Remember, that was the 3. It was an extremely low sum with only 2 cells. So the candidates had to be a 1 or a 2. No other combination will sum to 3. Now let's look at this cage with 23 as the sum for 3 cells. And if we look at the combinations tool, we see that only 6 plus 8 plus 9 equals 23. There are no other combinations, so we can easily put a 6, 8, and 9 in those 3 cells. Great. Sometimes you'll get a cage with a single cell and only one number. So obviously that cell is that number. You might find that in easier level puzzles, but it's not in this puzzle. So memorizing some key combinations can be very helpful, and with a little practice you'll get good at recognizing these combinations. For 2-cell cages, the following sums have only 2 combinations. If you see a sum of 3, it can only be a 1 or a 2. A sum of 4 can only be a 1 or a 3. A sum of 16 can only be a 7 or a 9. And a sum of 17 can only be an 8 or a 9. We found the 3. Are there any other 2-cell cages that we can fill in easily? Well, let's have a look around. Well, here's a 4 with just 2 cells, so this has to be a 1 and a 3, right? And let's see, here's a 16 with just 2 cells, so it can't be an 8 and an 8 because we can't repeat numbers, so it has to be a 7 plus a 9, right? And here's another 16 with 2 cells, so again, 7 and 9. Okay, any more 2-cell cages with sums of 3 or 4 or 16 or 17? Yes, here's a 17. So this has to be an 8 or 9. Great! Look how many candidates we have so far. Now, what about 3-cell cages? Remember, we found this cage with 3-cell numbers summing to 23, and that could only be a 6, 8, or a 9. So here's a list of key combinations you'll find helpful for 3-cell cages. The following sums have only 3 number combinations. 6 can only be a 1, 2, or a 3. And I don't see any 3-cell cages that sum to 6. Next is 7. That can only be a 1, 2, or a 4. So here's a cage summing to 7. So I can put in these cells a 1, 2, and a 4. 23 can only be 6, 8, or 9, and we found that already before. I don't see any more cages that sum to 23. How about 24? No. And what about 4-cell cages? Well, here are some combinations you should know for 4-cell cages. If you see a 4-cell cage that sums to 10, it can only be a 1, 2, 3, or 4. And a 4-cell cage that sums to 30 can only be a 6, 7, 8, or 9. So let's see if we have any 4-cell cages that sum to 10. No, I don't see any 4-cell cages summing to 10. And I don't see any 4-cell cages summing to 30 either. So much for that strategy. But we're off to a good start. When you see cages with these sums, you'll know right away which digits go there. So study this handy chart that I have here. Maybe take a screenshot of this for 2, 3, and 4-cell cages. You'll see these cages often, and the more often you do puzzles, the easier it will be to recognize. Okay, what next? Well, there's something called the 45 rule. Every row, column, or block has to contain the numbers 1 to 9, right? So if you add up the numbers 1 to 9, that is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9, you get 45. So the sum of all the digits in a row or column or block has to add to 45, and we can use this rule to our advantage. For example, let's take a look at this block, block 7. And if I add up all the complete cages in this block, that's these 8 cells, they add up to 38. But every row, column, or block has to add up to 45. So if the 8 cells add up to 38, then I need the remaining cell, the 9th cell, to be a 7 to get to 45. So this cell has to be a 7. And since this is in a 2-cell cage summing to 15, this other cell has to be an 8. Great. And now that resolves this 8-9 pair here in this cage. This can't be the 8, so it's the 9, and this is the 8. And here in block 3, we have a similar situation. These cages are all contained in block 3, and they contain 8 cells summing up to 15 plus 14 plus 9 is 38. So what's missing? And again, it's the 7. And since this cage sums to 10, if this is a 7, then this is a 3. Nice. And now let's play with this block, block 6. All the complete cages in the block add up to 36 without the 3 that we filled in. So with the 3, it's now 36 plus 3 or 39, but it needs to add up to 45, right? So what's missing? The 6. 39 plus 6 gets us to 45. And now if this cage adds to 13, then this cage has to be a 7. We're on a roll. Now, if one column with the numbers 1 to 9 adds up to 45, then two columns adds up to 45 plus 45, or 90, right? So let's highlight all the complete cages in these last two columns. Okay, that adds up to 85. There's just one cell here that is not part of a complete cage in columns 8 and 9. It's part of a cage outside of that. So these highlighted cells add up to 85, and it needs to add up to 45 plus 45, or 90, for the two columns. So this missing cell has to be a 5, right? And that means that this cell is a 4. All right, great. Now let's look at this block, block 4. We have a cage here that sums to 11. And at first glance, it looks like there are too many combinations for two cells that can sum to 11. But we can eliminate many of these combinations. For example, there's a 7-9 pair in the row, and they are locked into that row, so there can't be any other 7s or 9s in the row. So we can eliminate this 2-9 combination, since we can't have another 9 in the row. And we can eliminate this 4-7 combination, also because we can't have another 7. And we already placed a 3 here, so this 3-8 can't be right. So we know these cells have to be a 5 or a 6. Okay. But because of the 6, 8, 9 we penciled in down here, this cell can't be a 6, so it's a 5, and this is the 6. Great. Now, in the same block, we have a 2-cell combination summing to 12, and here we can see the possible combinations are 3, 9, 4, 8, or 5, 7. Well, it can't be a 4, 8 since we already have an 8 in the block. And it can't be a 5, 7 since there's already a 5 in the block. So these cells have to be a 3 or a 9. Oh, I just realized when I placed this 7 in column 8, that resolves this 7-9 pair down here. This is a 9 and this is the 7. And now this can't be a 9 anymore, so let's get rid of that. All right, let's look at this cage here. 3 cells that sum to 8, and there are 2 possible combinations. 1, 2, 5 and 1, 3, 4. But it can't be a 1, 3, 4 because we have a 3, 9 pair in the column, so there can't be any more 3s in the column. So this cell has to be a 1, 2, or a 5 combination. Now, while we're working on killer cages or killer Sudoku, you have to still keep in mind the rules of classic Sudoku. We have 2 7s here in columns 8 and 9, so there needs to be a 7 in column 7 here in block 6 in one of these 2 cells. And these 2 cells make up a cage summing to 15, so that has to be a 7 and an 8. But in this row, there's a 7-9 matching pair, and they're locked into this row, so there can't be any other 7s or 9s in the row. So that means this has to be an 8, and then this is the 7. Now, let's see. This cage here sums to 7, with the possible combinations of 1, 6. No, it can't be that because there's already a 6 in the block. How about 3, 4? No, there's already a 3 in the block. So these 2 cells have to be a 2 and a 5. And because of this 5, this has to be the 2. And this is the 5. And I can eliminate this 2 over here. All right, let's see. That leaves us with a sum of 14 with 3 cells. And a lot of possible combinations, but we can rule this one out because of the 6 and a 7, and this because of the 8, and this the 7, and this the 8, and this the 3, and this the 7 and the 3. So that leaves us with a possible 149 in these three cells. And here, this 14 sum has two possible combinations, but it can't be a 5, 9 because there's already a 9 down here. So it's a 6, 8 pair. Okay, let's look around. There's a 5 in this row and a 5 in this row. So this row needs a 5, and it has to be in one of these three cells. And if you look at all the possible combinations, look at that. Only one possible combination has a 5. So these three cells have to be the 5, 6, and 8. Oh, and I just realized that we have a 7 here in the block. So this has to be a 9, and this is the 7. So this can't be a 9 anymore, so let's get rid of that. And down here, this cage sums to 7, and it can't be a 6 or a 5. So this has to be a 3 and a 4. And since those are locked into column 2, there can't be any other 3s or 4s in the column. And that means I can eliminate this 4. Okay, now let's see if I can use the 45 rule somewhere else. Okay, these 4 rows should sum to 180, right? 45 times 4. 45 for each row, so 45 times 4 is 180. But if I add up all the complete cages here, let me highlight all the complete cages in the 4 rows. So that's all these pink cells. This 8 is not a complete cage, and neither is this cell. So this, without the 8, gives us a sum of 171 for all the highlighted cages. And let's add in the 8, so 171 plus 8 is 179. But the 4 rows have to add up to 180, right? Which means we are missing 1. So this cell has to be a 1. And that means I can get rid of these ones. So now I have a matching 4, 9 pair in the row. So this can't be a 9, so it's a 3. And then this is the 9. That is great. Oh, and there's a 9 down here, so this is the 4, and this is the 9. And now column 8 has just one number missing. These are 6, 8, so what's missing is the 1, and that means the only combination that adds up to 15 and includes a 1. Well, we already have a 5, 9 in the block, so it has to be a 1, 6, 8 combination. And since this is the 1, these two cells are the 6 and the 8. And here in this row, row 4, there are just 2 cells remaining. And what's missing? The 2 and the 4. So let's fill that in. Okay, now let's see. We have 9s in columns 8 and 9. So there needs to be a 9 here in one of these 3 cells. So that means even though there are a lot of combinations that add up to 15, we can just look at the ones that have a 9 in them, and that's these 2. And since there's already a 4 in the column, the only possible combination is the 1, 5, 9. And now that eliminates this 1 down here. So this is a 2, and this is a 1. And that means this can't be a 1 or a 2, so it's a 5. And that eliminates the 5 from these cells. And now block 9 has just 1 cell remaining. And what's missing is the 3. So this is a 3, and that resolves this 3, 4 pair. This is a 4, and this is the 3. And now this can't be a 1, so it's a 2, and this is the 1. Okay, this 3-cell cage can't have a 1 in it, so it has to be a 2, 3, and a 4. And this can't be a 4. We already have a 4 in the row, so this has to be a 4. Okay, let's look around. And so column 3 needs a 4 and a 6. But this can't be a 6 since the sum of this cage is 12, and you can't use 6 and 6. That would mean repeating a number. So that means this cell has to be the 6, and then this cell is the 4, which makes this the 8. Nice. And I can eliminate the 4 here and the 8 here. Oh, and the 9 here, I missed that. And this cell is a 1 or a 3, and let me go back here. I placed this 8, so this has to be a 6, and this is the 8, and that takes care of column 8. And this one here, another one I missed, so that means that this is the 3, and then this is a 1, and this is a 3. Nice. I wonder what else I missed. Eventually I find it. Okay, now let's look at some cages that are partially filled in. So here we have a 3-cell cage with lots of combinations, but we know there's a 3 in one of the cells, so that eliminates all these combinations, and we're left with these 3 choices. Well, it can't be the 3, 4, 7, since both a 4 and a 7 are in the row. And it can't be the 3, 5, 6, since there's a 5 in the row. So it has to be the 2, 3, 9. So these cells are either a 2 or a 9. And that means this cell can't be a 9 anymore. So now the 9 has to go here. Okay, now let's have a look at this 16 cage here. It's just 2 cells across, and it needs a 3 in it. And it can't be a 9, 4, 2, or 1. So I can cross off all those combinations, and I'm left with a possible 5, 6, 7. Well, this can't be a 7. Here we have another cage that sums to 14, and it already has a 6. So it's either a 1, 6, 7 or a 3, 5, 6. But there are 3's in both these columns, so it can't be a 3, 5, 6. So it has to be a 1, 6, 7. So these cells are 1, 7. But there's a 1 in this column. So this is the 7 and this is the 1. And we can eliminate this one. And now we have column 3 done. Let's see, column 2 is missing a 1, 2, and a 5. So one of these 2 cells has to be a 5. Not sure if that helps. And column 4 needs a 2. We can't have a 2 in these cells because of the 2's here in rows 8 and 9. And this is already a 5, 6. So the only place a 2 can go in column 4 is here. And now that resolves this 2, 4 here, since you can't repeat digits in a cage. And this is a 3-cell cage, so it has to be the 4, and then this is a 2. Okay, what else is missing from this column? The 4, 5, 6. So this cell can be a 4 or a 6, and this cell can be a 5 or a 6. And actually, these 2 cells can't be 4's, so this cell has to be a 4. Nice. And that means this cell is either a 6 or an 8. Okay, so now we have a 3-cell cage here that sums to 17, and we know that it needs a 4, so we can eliminate all of these combinations, and we are left with 4, 6, 7, or 4, 5, 8. Well, it can't be the 4, 6, 7, since this would have to be a 6, and then there's a 7 in the column, so that won't work. So it has to be the 4, 5, 8, and this is the 8, so this is the 5. And that resolves this. This is now a 6, and let's get rid of these 6's, and these 5's, and these 8's. So that makes this a 6, and then this is a 7. And now this is an 8, and this is the 6, which makes this the 8, and this the 6. And I didn't finish this cage. This has to be a 6, and this cage, this has to be a 5, which resolves this 1, 5. This is now a 1, and I can eliminate this one. And this 5 resolves this 5, 8 pair. This is the 8, and this has to be the 5. And now this cell has to be a 2 or a 9. And one second, I placed a 2 here. So this is a 9, and this is a 2, and then this is a 9. So that leaves just a 3-4 combination in column 6, and this can't be a 4, so it's a 3, and then this is a 4. And that resolves this to 3. This is now a 2, and then this is a 3 and a 4. And there's one cell left in this row, and it's a 3, which means this cage sums to 10. So the remaining numbers are 2, 5, and this can't be a 5, so it's a 2, and this is the 5. And that resolves this 5, 9, this is the 9, and this is the 5. It also resolves this 1, 2, this is now the 1, and this is the 2. And now we have just one cage left, and it has to be a 1, 7, and this is the 7, and this is the 1, and the puzzle is done. I hope you enjoyed this solve with me. It's a little different than the classic Sudoku, but still it's lots of fun to do. Thanks for watching, everyone, and as always, I hope you learned something.